Hello, hi, and welcome to my YouTube channel. So, most probably you will be thinking about what I am going to present right today. So, today in this video, I am going to cover on the project that is actually based on the line follower robot. And then, this is not actually the line follower, but this has some certain specifications that can really track what distance has it traveled using the encoder, and then it can display the steps on the LCD. Oh my god, wow. Again, it can display the current sensors output and the voltage sensors output on the LCD, and that will let you know what the current does it drawings from the circuit. So this is the proposal for our project. According to that, our concepts should be based upon these three points. Means that it should be reliable, cost effective, and the collection of various types of data that it generally will hold. So coming towards our point, these are some estimated budgets that we generally did, and then you can see here we have used ultrasonic sensor, servo motors, LED bar graphs, two Arduino Unos, and then here you will see that IR sensors and L298 motor drivers. And now coming on towards what type of the working it is doing, so we will see here. So this is the block diagram of our project. So it's basically consisted of the two or 8 mega 3 to 8 Ps, and first and the second controller. So here you can see that the 8 mega 3 to 8 P is connected with the with a motor driver, and then a power supply. These two motors are connected with the L298, and so the 8 mega 8 3 to 8 P is processing or whatever, giving the PWM to the motors by help of the L298 driver. Here is the SD card module, and then here you can see that the servo motor is also attached that will work as any interrupt. So these are the IR sensors that senses and follow the line. Again, we coming on towards this. So this is basically the LCD display. This is connected with the 8 mega 3 to 8P and a LED bar graph, tachometer, voltage sensor, and current sensor. And again, you can see that the power supply is connected with that. So you can see these are connected in such a way that they the output of the input of this voltage and the current sensor is directly connected with the output of the motors. That it means that the motor drawing current and the voltage will be coming on towards these sensors, and then you will see that it will give the output to the particular binary BCD conversion in at mega 3 to 8p second controller, and then display it on the LCD. So here you can see that the port D2 to 6 pins are connected with the IR sensors output, and then here you can see that A3 and A4 are connected with the ultrasonic sensors, and the motor driver are connected with the first 4 analogous pins. And then you can see that the motor driver's port B is connected with the SD card module, and the 8th pin is connected with the servo motor, and these are S and D not means that SCK clock select and chip select, or whatever it is, MISO and MOSI and CLA clock. So this is connected to the respective pins as prescribed in the Arduino board's output pins. Actually this has been written on the pins of Arduino. These are specific pins that are being used only for the specific operations, just like the serial communications and the SD card module operations. And now we are going towards the LED bar graph. Here you can see that the current sensor, voltage sensor, and the tachometers are connected with A0, A1, and A2 respectively, while all the remaining A3, A4, and A5 are free. And here you can see that according to this specific coding, here is the LCD display that is connected with the, means that here you can see that 8 is connected with the register select and enable D4, D5 respectively, and then you can see that the tachometer is connected, potentiometer is connected with the VEE and ground in order to just contrast the display. Here is the LED bar graph, and taking the inputs from the LED bar current sensors and displaying it on the LED bar graph with the help of the voltage sensor. So these are all the parameters, and again we are using the timers in ATmega 328P that counts every tick of the timer and then display it with the addition of new number after the passing of every previous number. And now we will see that coming on towards its code. So this project is consisted of basically two types of the codes. So the first code here I'm going to explain is for the LCD display in which the current sensor, U sensors and the voltage sensor is connected. Now here you can see that we have, I'm sorry for the delay, so defining these pins for 6 pins in the LCD crystal in Arduino IDE just makes let you know about how to define these pins, means that this is enable. Actually the first bit is chip select and then enable and then VCC ground or whatever. These are the D0, D1, D2 and D3 with the 4 pins, and the 4 pins are free. There are two types of the communications with the LCD, means the 4-bit communication and the 8-bit communication. So in Arduino IDE we do the 4-bit communications. So these are the chip select and the enable pins, while the other pins that are VCC ground and VSS. So all these pins are applied externally with the batteries and potentiometers in order to set the contrasts. So here you can see that the input analog A1 is assigned, means that it is analog input, and then float we are all these characters are just assigned. So these are the two values that are the resistors on the voltage sensor module. These are the two resistors that are attached. So we have just set these values in order to calculate the voltage output, means that we will apply the voltage divider rule in order to apply these two values to the output. So here you can see that the U sensor is connected with this third pin of the analogous pins, and then you can see that start time, end time, steps, old step, all these values we will further discuss how these values are working. So this is the current pin that is connected with the A node, and sensitivity is 66, means that sensitivity is ranging from 166 to 185 millivolts per ampere. So the sensitivity of the current sensor is ranging from 66 to 185 millivolts per ampere. So in order to make the current sensor more sensitive and give the values at the output with the high variety of variation with the low change in the input of the current sensor, so we will just set the sensitivity of a current sensor is equals to 66, and then again initializing this variable, and then you can see that the offset voltage is 2500. It means that the 0.25 millivolt variations, and this and here you can see that if the current sensor is giving us the output of 0 volts, then the 0.25 millivolt variation will be always present in this current sensor. So in order to remove this zero error, we are just providing the offset voltage. So whenever the 0.25 millivolt will be provided by the current sensor, this will be just like the zero at the output of the current sensor. So here you can see that the int f1 even these are the integer variables has been declared, and then we will set these variables as input and output. Basically these are the numbers that defines the pin in defines the digital pins on the Arduinos. And here you can see the serial dot begin. It means that these are the types of the this is the command line that is being used for the 9600 baud rate serial communication between any module. For example, I am just implanting the SD card module, so serial.begin is necessary in order to have the communication between the Arduino and the SD card module. Here we see that LCD.begins means that this is a 16:4 LED that I am using. Again, here you can see that the pin mode sensor, that is input output mode. So here you can see that I am just going to this I'm just going to set these different pins as an input output. So these pins will be working as an output, means that these are the pins that we are going to use for the LED bar graph. Here you will see that first F LED is turned on, then after a delay of 500 milliseconds E is turned on, then DCBA. So here you can see that the LED will be turned on sequentially from low to high LED bar graph, and then you can see that again when the LED first LED means that this is just working like the stack overflow, and the first stack is empty and means the first in last out. So now the first LED that burned, now the first LED is that is turned off. So this is the sequence of this LED paragraph. So here I will show you the simulation in the Proteus. So you can see that it is just working with a delay that is more than the actual hardware, but actual hardware is working very fast. You can see that it is just filling up the LED bar graph just like in the UPS batteries, and then again it is filling and then defilling will be done, and then the voltage at the output will be displayed. So again you can see that the LED bar graph is defilling, so it will take a lot of time, so I have to just move on towards the code in order to explain how does it works. So these are the just commands and the group names that will be print, and it's quite simple. Was just setting the cursor at the particular position and then printing these values will be quite common. Now we will move on towards the start time. Simply entering commands in start time is equals to plus 1000 is equals to the 0.1. So millis command is that command that is used to save the previous time, and then when this command is being called, the previous previous time is being added in the next value, and then it will give you just like the for loop and I plus plus command is being executing. So if it is reading the digital sensor, so the while loop will be called for forever, and then it will print the steps on the LCD screen. So here you can see that the steps are being printed on the LCD screen and the value is being taken on the A3. So here you can see that when I just press this, every step is being called on the LCD screen. So the steps are being printed, and now we will move on towards the voltage. So analog read is equals to analog input. Analog input was first declared as at A2. So now the value this is the formula for BCD conversion, binary analog to digital conversion, and then V in is equals to, this is the voltage divider rule that we will be extract from the V out multiplied by R2 divided by R1 plus R2. So this, so here is the command that you can see that if VIN is equal to or greater than 11.88 volt, means that all the LEDs will be turned on. So if the voltage is between 11.46 and 11.28, so the first LED will be turned off. Similarly, if the voltage is far more low, then the LEDs will be turned off, and then if the voltage is much lower than the previous one, the LEDs will be, 3 LEDs will be turned off. Similarly, the same pattern is repeating as long as the battery is fully drained out, and this is the 10.53 threshold voltage at which our battery got drained out, and that was not working well. So this is the code for LED bar graph, and now we are moving on towards the again you can see that for current pin, this is the analog to digital conversion formula, and then you can see that we are just subtracting the offset voltage. Means that the current sensor always gives the offset value something like 0.25 millivolt, and then you can see that we have divided it with the sensitivity. So by doing this, we are just going to make our value more sensitive, and the offset value is 0 instead of 0.25 millivolts. Here you can see that current values are being displayed, means that this current value will be storing the values that are being taken from the current pins, mean that A1, A0 or whatever we have assigned before. Now this is the code for LCD, and now we are moving on towards the code that is simple and not a quite difficult one. And here you can see that we are using the ultrasonic sensor for trigger pin and echo pin. We are using the two analogous input pins. One is output, that is trigger, and the second one is input, that is A5 or echo pin. These are the standard libraries for SPI serial communication and SD.H. We will communicate with the SD card in this, and then you can see that servo motor we are using, and we have just included this library, and we are using the ultrasonic sensor, and we have just included this library as well. So first I just named file that I am going to store in SD card named as my file. So here you can see that the int distance is equals to 100, and now we are just going to apply the pin numbers on this command. This is the new ping.sonar command, take pin, echo pins, or maximum distance. Maximum distance will be 200, and then this is the maximum range of this ultrasonic sensor. And now servo is equals to servo motor, so I have just used this name servo motor. And here you can see that in white setup there is always this command used. So serial.begin is equals to 10 means that 10th pin is being used for this serial communication. And here you can see that the servo is attached with the 8th pin, and then the motor servo motor dot write means the 150 command is gone to the servo motor, and that will arrange it to the specific angle being coded in the motor. For example, it will move 115 degree. Actually, I have used a motor that is 180 degree maximum rotation. So again you can see that it will arrange it in position first, and then after some delay it will read the distance. So distance is equals to read ping. Read ping is the command that is that gives us the distance, and then these are the pin modes that will work as an input, means that the output of the IR sensors will go into the input of these Arduino pins, and then output will be A1 A2. These are connected to motor drivers in order to drive the motors. And then here you can see that this is the pin that we are being using for the PWM. Here is a distance, left distance, right, first initialized with a 0, means that it will after every completion of the command the loop will call again and set the distance to the 0 with a delay of 50. And then you can see that the distance is less than 2500. So if the distance is less than 25 centimeter, then it will look right and left and then stop. So if the distance is greater than, here you can see that if the distance is less than, it will stop, else all this command will be executed. So as this, all the command will be executed. For example, we have just declared this all as integer a, b, c, d, and e. So here you can see that the digital read is equals to 2, means that for it will read this, this. So digital reading is being done here. So we are just going to here you can see that if a, now we are checking that this pin is low, this pin is low, means that the center tape is black, so it's giving us the output 1. So these are all the logics that we are using, means that the central pins will be high, then this will move forward. So this is the actually analogous value that we are giving at the output. So here you can see that the 255 value means that the counter will count up to the 255 in order to give us the full well, you can say that 5 volts. So this is the PWM that is being applied to the two enable pins. 100 means that the counter will count up to the 100 and then it will turn off. So the width of the modulation is reduced, and now it has reduced the speed. Actually, with the 12-volt battery that we have connected the cells in the series, that has increased a very high range of the voltage or current, so that the motors were you can see that looking like they are mad, but we have just controlled this with the help of this modulation, and then the speed of the motor has been reduced and controlled as well. So now we are going on towards the servo motor. Here it is looking right. So the look right function is here, that the servo motor will write to the 50, means that it will turn left, and this is a specific value that's provided to the motor in order to rotate left. And then you can see that the distance is equals to the read ping. So here you can see that means it will rotate left, and then the distance will be recorded, and then return distance command is executing. Then it will look left. Look left means that we can see here that the 115 is being subtracted from the certain value, and then you can see that it is being executing, and 115 is added with some certain value, and then it is going to look right. So this is the specific coded value that the motor is being looking left or looking right. So basing upon these certain adjustments, in order to create the best, well, you can see that look left and look right. So means that I'm just creating this, it will look left or right, means that it will shred it, short its head in the no conditions, mean that we just shook our head in the no conditions, just like no, I just don't, so if we shook our head, so this is the same condition that is being executed with our robot, that it is um, saying that no, please create a more distance. Oh, let's see. It seems to got a very good job. So we are going towards the if. So if here you can see that centimeters equals to 0, then centimeters equals to 250, means that in some conditions, when we see that the ultrasonic sensors also, when it is out of the range, it gives us the 0 value. So you can see that we have just called this function in read ping, means that mm, this distance is out of the range, so the maximum distance can be 250. So the 250 will be returned as an output, means that the centimeter becomes 0, the values become 0. So we are just uh, saying that the values become 0 when it is out of the range of ultrasonic sensor, means that the distance is too far away from the ultrasonic sensor. So this is the function that is void store with the PWM remains same. However, we can set the PWM 0, means that we are setting it at 0, and however we can set is as, means that if the enable will be turned off, then there will be no any command executing like here. So by setting the PWM 0 or by setting all these are 0 and PWM 1, it doesn't make any lot of difference. So this is the f function, means that it will be the forward function. So this is the SD card, so my file sd.open, so the file that we have saved as test.txt file, so we are going to just write in that txt file when we open the SD card, and then you can see that test.txt. so here you can see that my file again I open. Now we will after that opening the file, the serial print will be opened, so print ln means a new line in which the forward.txt will be printed, so we don't have to write it again, and my file dot close. After execution of this function f in the forward command, you can see that the forward will be printed once. Again you can see that if we move on towards the right side, or any, for example, if we detected the obstacle, same function that I have explained earlier will be executed, but here you can see that OBS means the obstacle, so the obstacle will be printed in the my file. So this is the certain example that I have already executed, is this text file. Here you can see that the text file is here. Now we have just opened it. Here you can see that after observing that the object is not means that after seeing that there is no any tape, so it will rotate, and now it has moved left. After observing that the left sensor is turned on, again it seeing that there is no any tape, and then move right, and then you can see that it will move forward, and this is the entire part of our robot that it has recorded in the SD card module. Now coming on towards the simulation, here you can see that again turning off the simulation and turning on the simulation, you will see that this is executing with a little bit taking of time, and when you will see that in the hardware it is executing with a lot more speed. So Proteus just take a time in order to execute its code on the Arduino, and Proteus itself is running the simulation on the softwares. So first you will see that the LED is turned on, and then LED bar graph will be turned off, means that it is just initializing the robot and let us know that the robot is working in a working condition, all the Arduino is working properly. So the chip trails will be printed, and then you can see that our names will be printed. So it's just taking using a lot longer delay. At the same time, you will see that this is the code for the IR sensors and the SD card modules, and then if I am going to debug it, you will see that the forward is being printed, and when I will just, you can see that, use that command. So here you can see that this write will be printed in the and then when I turn on the left sensor, means that the sensor is moving, our robot is moving, so this is the left one. Here you can see that left one, and then if I just stop. So here you can see that the robot is moving backward in order to coming on towards the line that is being that should be that he should follow. So this is the SD card working. Here you can see that the value provided to this servo motor is 41.3, means that it has uh, turned to the 41 degree in order to stabilize its position to the forward direction in order to move the sensor in the front of it. And after, you can see that when I am just going to turn on the middle sensor, the forward command is executed. Both of these motors are turned on with the PWM. Here you can see that this PWM is applied and this is just vibrating or pulsating. So this is motor. So I have just attached this motor with the like this. Here you can see that the current sensor is measuring the current and again refreshing its values, and then you will see that it's giving the 2.5 amperes, means that this motor is currently drawing 2.5 amperes of the battery, means that it's a lot more, means this motor is just draw the all over current. And then you can see that the LED bar graph is fully turned on according to our code. So here you can see that the voltage is 12.5, means that the LED bar graph is fully turned on according to our code. The all the LEDs were turned on, then it will be greater than 11.88. So this is greater than 11.88 means 12.5. So all the LEDs are turned on, and same as the voltage is measuring is being measured. Now I will let you the wheel encoder. Wheel encoder just give us the output in the form of 0101. So every one is recorded and saved, and every incoming one will be added to the previous one and then add up to 2. So the every one becoming after coming after 2 will be add up to 3. So here you can see that when I just turn on and off this toggle, just like a wheel encoder, you can see that the RPS means that these ticks divided by 20 will be recorded here, and you can see that these values are being recorded here. So this was the work for this simulation block diagram. And now the last thing, last but not least, we will come on towards the hardware here. Here the robot is working properly on the breadboard. However, we have just made a PCB, but it's working very well. There are certain restrictions that made it not work on the PCB, but it is working now properly. Here you can see that the 13.7 volt is being displayed, and now when I remove the cover charging, you can see that current is also reduced and voltage is also reduced, and the voltage level at the LED bar graph has also been reduced. Now again applying the output current to the motors, you can see that 13.6 volt is now being applied, and LED bar graph output voltage value has also been increased. Here you can see that this will require some configuration to be set up, and this is a PCB that I have implemented, and this really made me to get a professional look, and I have really enjoyed this project very much, and this gave me a lot of the lessons to be learned in life.